Today we're going to introduce what are called exponent rules. These rules are basically in place so that we can multiply and divide in certain situations with exponents. Just as a quick review from the last lesson, the a represents the base and the m represents the exponent. It is important to know that you can only use these exponent rules on exponents that have the same base. So I have two groups here, and you could actually only use exponent rules on the first group. And that's just because you can see group 1 is made up of terms with the same base. They're all a's. So group 2 cannot be used because we have a bunch of different bases. We have an a, b, and a c. We now have a couple specific rules that I'm going to introduce. The first one is the product rule. So this tells us how we can multiply exponents of the same base. And we do so such as you keep the base the same and then you add the two exponents. So for example, if we were asked to evaluate 2 to the exponent 3 times 2 to the exponent 2, first check, yep, we have the same base, they're both 2s, so we can proceed with this rule. So then by this rule, we know that it's equivalent to 2 to the exponent 3 plus 2, which is simply 2 to the exponent 5, which is 2 times 2 times 2 times 2 times 2, and then finally our final answer of 32. The quotient rule tells us how we can divide exponents of the same base, and that is you keep the base and then you subtract the two exponents. So for example, if we have 6 to the 3 divided by 6 to the 1, first check, yep, we both have the base of 6, so we can apply this rule. And then it's as simple as 6, keep the base, and subtract the exponents, 3 minus 1, which is 6 to the exponent 2, which is 36. And our final rule is the power of a power rule. So anytime you see an exponent raised to an exponent outside of the bracket, you would use this rule. And you would do it such that you just multiply the values of both the exponents. So let's do an example. If we had 4 to the 2 all raised to the exponent of 3, we would follow this rule and write it as 4 to the exponent 2 times 3, which is 4 to the exponent of 6, which is 4 times 4 times 4 times 4 times 4 times 4, which is equal to 4,096. Now that you know the product, quotient, and power of a power rule, let's get into some examples. So here we have a to the exponent 3 all raised to the exponent 2 times b to the exponent 2, and then divided by a to the exponent 5 times b. So it's important to remember that when we're approaching these questions, we still keep in mind our rules of BEDMAS. So by BEDMAS, we know the first thing we have to tackle are these brackets right here. And to do so, we use our power of a power rule, which states that we multiply these two exponents together. So our next line would be a to the 6, b to the 2 divided by a to the 5, b. Now second, according to BEDMAS, is division or multiplication. So we know we can't do multiplication because the things that are being multiplied, the a and the b here, aren't the same base, so we can't use the product rule. So let's proceed to do division, which we can do because we have a's divided by a's and b's divided by b's. So by our quotient rule, we know that we simply subtract the value of their exponents. So this is going to turn out to be a 6 minus 5, and then b raised to the exponent of 2 minus 1, which then works out to be a to the exponent 1, b to the exponent 1, which we know is the same as just a and b. Let's look at this final example. So we could approach this two ways. We could start right away by evaluating each exponent and then going through the multiplication and division. However, I wouldn't suggest that because it's too difficult to figure out a1 to the exponent 2 times 9 to the exponent 2, and then that would be a huge number, and dividing that by 9 to the exponent 4. So instead, why don't we convert each of these into equivalent exponents with the base 3, and then use our exponent laws. So for example, 9 can be converted into 3 to the exponent 2, and then still raised to the 2. And 81 can be converted into 3 to the exponent 4, and then still be raised to the 2. And our base, 9, can be changed to 3 to the exponent 2 and still raised to the 4. Now we'll solve this using our power of a power rule for each of the terms. So it becomes 3 to the 4 times 3 to the 8, all divided by 3 to the 8. And then we will go about using our product rule, which becomes 3 to the 4 plus 8 divided by 3 to the 8, which is then 3 to the 12 over 3 to the 8. And finally, we use our quotient rule, which gives us 3 to the 12 minus 8, which is 3 to the 4, 3 times 3 times 3 times 3, to get our final answer of 81. And as you can see, those were much easier numbers to deal with than if we were to just solve these right off the bat and have to multiply and divide big numbers. So these rules, such as the product rule, power rule, and quotient rule, make problems like this a lot easier to solve. And that is the completion of working with exponents and exponent rules.